Alright, hello everybody. First of all, thank you all very, very much for coming this morning. I realise there may be a few sore heads after last night, so hopefully this morning's session will ease you in gently to the rest of the day. I hope you don't mind. I'm going to ask everyone to wave and I'll tweet the photograph and you can get it later. I mean, you waving, not me. Yeah? Right. So, if there's one thing that makes everybody laugh at a SQL Server conference, it's when someone mentions Microsoft Access as a database. Yeah? So when I say 1, 2, 3, access, I want you all to smile, right? Right. 1, 2, 3, access. Thank you. Perfect.
Yep.
Thank you. That's lovely. So thank you all for your time coming this morning. We're going to talk about analysing your data with PowerView. I will show you some ways in which we can look at big data as well. Now, I know that there's a lot of sore heads after last night's party. I hope you all had a nice time. But I thought I would start off by showing you some of the worst data visualizations that you might come across. And hopefully you won't do any of these mistakes that you see other people doing. And then you'll see why PowerView is a good option for people who do silly things with data. And you probably quite often see charts and graphs and think, oh, that looks terrible. Well, let's have a look at some of the work that some other people have done. Okay, so this is my session. So before we dig in, it's just to explain what data visualization is. It's a way of representing data, which means that you're trying to respond to data that is fast-moving and fluid. It's in a dynamic environment. So it's not the same as painting a picture with numbers. Essentially, what you're doing is giving someone the data and then letting them make up their own mind. You're not making up their minds for them. Now, as you probably know, there's so much data around at the moment. Yeah? So what's happened is computers and the internet, information technology, has supplied us with an awful lot of data. But with that, we're not sure about actually finding any useful information, knowledge or wisdom from that data. There's so much of it. So the reason that data visualization is important for me is because it's trying to make sense of that data that we see around us, to change our environments and to change the way things are in the organisation. So by data visualization, we could give people tables and just give them the numbers. Well, actually, almost 50% of our brains are dedicated to visual processing. So it's something that's actually really important in the way that we consume information. So in our bodies, 70% of the sensory receptors are in our eyes. So when you consider our senses that our fingertips, our sense of touch and smell, we have so much dedicated to vision. And when we look at data visualization, we're trying to leverage that ability of our bodies, of us, to understand information visually. That's what we're trying to do. Okay, so data visualization and PowerView. PowerView is one of Microsoft's latest Power BI tools. It's one of the ones that's it's become really popular really quickly. And the reason for that is it's very simple to use. It's very easy. It's a bit like Spider-Man used to say, with great power comes great responsibility. In PowerView, you don't actually have that much power. All you do is click and tick. But that means that you have no real responsibility as the PowerView user. You're not actually changing any data. But in order to make good PowerView models, what we have to do is cleanse the data, sanitize it. we have to describe it, analyse it, and look after it. So I always get a bit wary when I hear people say things like, we don't need data warehouses anymore. I don't think that's true. I think we still must have a good technical infrastructure. The data visualization is just the icing on the cake. Yeah? So let's have a look. So PowerView actually does contain some 3D PowerView does contain some pie chart visualizations. But the thing with pie charts, and I'm going to show you some, is that very often they can be quite difficult to read. If you've got a lot of slices on a pie chart, then it becomes quite difficult for people to compare. And that's what people want to do when they are looking at data. They want to say, well, this is greater than that. Pie charts can only really deal with one dimension as well, and you have to be very clear about the data that you're showing. We tend to find it easier to compare wedges of the pies which are closest to 12 o'clock. If you imagine the pie chart as being like a clock, what we have is it's easier to compare the slices at the top than it is to do the ones at the side or at the bottom of the pie chart. And next time you show someone a pie chart, you can do this. What to do is put the slices at the bottom or slightly off centre, and you start to see people moving their heads very slightly. Yeah. Sometimes I show people pie charts just to see the whole room do this, because that's what happens. But I'm being gentle with you this morning, as I said, so heads. So here we are. Pie charts basically take up a lot of space just to see one thing. Now this is quite a well-known pie chart by Fox News. Can anybody see what's wrong with it? Yes. Yeah. It doesn't add up to 100%. Good old Fox News. If you were ever looking for some good data visualizations like that, Fox News is your place. Yeah. Now the reason that this pie chart doesn't work is because they asked people a multiple choice question. Yeah? So people could give more than one answer to the same question. So sometimes people did actually say, well, I'll vote for Huckabee or I'll vote for Romney, and put down both. So that's why it adds up to more than 100%, because people had more than one vote. It's very easy to do that with pie charts. They can also be a bit misleading, and I don't know if you can see this very well, but the bigger blue segment says 49%, and the smaller one says 50%. What happens to the remaining 1%, I'm not sure. But what the problem here is that for some reason 49% looks closer to 60%. It's not even accurate, so it's not just wrong, it's also inaccurate. And this was taken from a UK newspaper. Yeah. So shame on us, getting that wrong. Sometimes people do something like this. Yeah? This is a real pie chart, 100% if people were not sure. So the problem with this is it uses up a lot of ink on the page. In data visualization, we have something called the data-ink ratio. And what you're trying to do is display a lot of data without using a lot of ink. So what we're saying by that is don't use ink unless you absolutely have to. And the reason for that is we are trying to make things as clean and simple for the people receiving that information as much as possible. Yeah? So that's called the data-ink ratio. So you're trying to display a lot of data with not very much ink. And the problem with pie charts, apart from the mysterious reason why this one occurred in the first place, is that it uses a lot of ink to tell you just one thing, that if 100% of people were not sure. What happens as well is this is taken from Google. There's an analysis of the shopping. So the thing is, with pie charts in particular, is that people are not very good at telling the area, and they're not very good at telling angles either. So that's a problem in data visualization. What happens is people misrepresent the area. They don't always understand it very well. I delivered my first data visualization session at a conference in the UK called SQL Bits, and I asked the audience, I put up a pie chart that had just simply 3 slices. I took off the legend, I took off the numbers, and said, tell me what the medium-sized slice is in terms of a percentage. And the answers I got back from the crowd were very interesting. I got 16%, someone else said 55%, and lots of numbers in between. The answer was actually 40%. So what surprised me is that a very data literate audience who deal with data all the time managed to get a pie chart wrong that only had 3 slices in it. There was 2 gentlemen in the audience who got it spot on correct. They were both Royal Air Force pilots, I had been in their previous careers. They were taught to read dials very well, and that's why they had got it right. So we think we know more than we think we do sometimes with data visualization. So it's quite difficult to read the angles. We actually need the extra information to help explain the numbers to us. And that's a problem, because I believe when you do a data visualization, you should not really have to add a paragraph of text in order to explain that information. Okay? This is one of my personal favourites. So you can see what I mean. You can't compare very well. It's very difficult. And what this one does is a bit more subtle as well. It uses the same colour again and again to mean different metrics. Yeah? That's not good, because when you look at the legend, say for example it's got 3 or 4 yellows. Which yellow matches which particular legend item? That means that you, as the viewer of the data, have to do a lot of work in order to understand the pie chart. It adds an obstacle between you and the data visualization on its own, and that's not good. What you can find is that you might get a corporate palette. So perhaps your organisation has a series of numbers, a series of colours, and that's what you have to use in your organisation in order to display data. And that sometimes looks really nice on a website, but it can look terrible in a data visualization. I worked for one organisation that had 4 colours on their palette. And I said, well, what about if I want to show 5 things? 5 bars in the bar chart. And they said, reuse one of the colours. I said, no, because what happens is when they do eye tracking studies of data visualization, people spend a lot of time going back and forth initially from the legend to the chart, from the legend to the chart. And in data visualization, we're trying to make things as simple as possible for people to understand. So we're trying to reduce the amount of time that people's eyes bounce back and forth between the legend and the chart. Because if they're doing that, they have not understood the whole chart then. They need to be helped to assimilate that information very quickly and then move on to compare the items within the chart. That tends to be the next step of visualizing the data. So 3D is something, when I show you Power View, you'll notice straight away that it does not have any 3D in it. Yeah? Now there's reasons for that. People don't always read 3D very well. It does not always add anything to the chart. It can also confuse people a little bit. The other side of 3D is that it can make the charts look pretty. So the thing is that you have a balance between making the chart aesthetically pleasing. You have a balance between making the chart look nice and being accurate. And sometimes people make the choice to make it look nicer rather than be totally accurate. So it depends on why you are doing the chart. I prefer to stay accurate. But what this They're known as trellis charts, and Power View gives you these. And the idea is that you have a chart with lots of little charts in it. I'll show you how to build those. They're quite easy in Power View. And the idea is that you can compare horizontally and vertically. And what's nice about that is you then don't have to use 3D, because you've got lots of smaller charts within a bigger chart. You have to make sure the axes are totally aligned, because otherwise, if they're not aligned, each chart will be a bit misleading, sat next to its friends. So the thing is that Power View automatically aligns the axes for you, so it already has some of these data visualization principles embodied in it. Okay. Sometimes people use pictures in order to explain data. Perhaps someone can explain this to me, why 75% of US adults suffer from dental anxiety. That's probably true, but why they've coloured 50%, I'm not sure. So these are very simple ways in which people can get things really wrong. Here's another example. Now, at the first glance, this looks quite pretty because it has nice colours in it. But the problem there is that it's using area and angles, mainly area, in order to represent a value. And what's worse with this one is that it's actually quite difficult to compare, because up here we have the police being something like 8, they're given the value of 8 million. But then the problem there is that some of the charts, some of the squares next to it are actually bigger, but they're smaller in terms of actual value. So again, the area is not representing the value. So something like this is very nice because it looks nice, but that's all it gives you. The actual numbers and the area are quite misleading. So, what is business intelligence about then? The objective of self-service business intelligence is really about trying to let business users find their own way in understanding the data. It's about trying to give them the ability to self-serve so that they can go and create their own reports without having to disturb you, for example, the IT person or the report writer. So the thing is, I don't think I've ever met an organisation who has finished writing the reports and said, that's it, we're done now. People just want more and more reports and more data. So you get to the point where the business users are not happy because they are not getting the data they want, but you're working really hard to get those reports out the door to people. So the problem there is if we try and give the business users some way of self-serving their own reports, that eases the pressure of the IT department or the report writer, who's not getting badgered every 2 minutes for another report. Because what happens then is, by putting business intelligence and data visualization in the hands of the business user, they can surf the data if they want on their own, and they don't have to keep trying to engage with IT to answer business questions. Because if you're analysing data, that can disturb the creative flow when you're looking at data. Because when you start with data, very often you don't have a specific hypothesis. You might just be looking at the data. In business intelligence, you tend to get 2 types of business questions. And answering these 2 questions helps you to choose your technology for that business user, believe it or not. So we get business puzzles, and they are very well-defined questions with a very well-defined answer. So that might be something like, how many sales did we make in a particular product for the last year? And there's a very correct answer for that. But then you get business mysteries as well. And what they are is where the business user doesn't really know the information that they're looking for. What they're trying to do is basically take the data, see what pops out at them, and then generate hypotheses from there. So they're the sort of business user that don't know what they don't know. They don't have a defined question. And these business users are actually very hard to make a data warehouse for. Because when you start with a data warehouse, you usually ask, what are the business questions you're trying to answer. And you do that to get the grain of the data warehouse, according to Kimball methodology. And then you start to build out your metrics and dimensions. But if your business user says, well, I don't know what you mean by business questions, I just want the data, that's more difficult to build a data warehouse for, because they can't tell you what the business questions are. And that's what self-service business intelligence is about. Now, there's an author called Malcolm Gladwell who wrote books by Outliers, Genius and Blink. And what he talks about is he talks about the Enron situation. Enron was a very, very large American company who went bust. And you may have seen the pictures of people walking out of the Enron building with boxes of paper. You know, and that's what they did, because they had all been made redundant and the place had imploded. Now, what Gladwell said is that the data that Enron was going bankrupt was actually there. It's just people did not have the tools to analyse that data properly or to join the dots between the data and then see that the situation at Enron was much more serious than they thought. Basically, that company was buried in data. They had so much of it, they couldn't see what was going on down at the bottom, and no real way of joining up the dots between the different environments. So when that happens, we see in the Enron case, what they were trying to do was use puzzle tools in order to solve business mysteries. So if if your user group are asking business puzzles, then you can use things like Excel and reporting services. They're very structured reports that allow you to answer very specific business questions with a very precise answer. But in order to deal with the business mystery persona, what you do give them is you give them Power View or give them Power Map, because all you do is give them a model and off they go. They click and tick and do their own analysis. So have a think about that next time you're starting a business intelligence project. Who am I speaking to? Am I speaking to a puzzle person or a mystery person? Because if you try and give a mystery person puzzle technology, they'll just get frustrated. So I had one user who's a report writer, who said to me, my reporting services report is a bit slow. And I said, okay, I'll take a look. And she showed me this report and it had 19 parameters. Does anybody here use reporting services? A few people? Yeah, half the audience roughly. So as you may know, with reporting services, if you add in a lot of parameters, it runs really slowly. The truth is, it runs like a dog. Yeah. It's just that simple. Don't have any more than 6 parameters in reporting services. So I said, so why have you got 19 parameters? And she said, well, I want to add in more. I said, no, don't do that. And you break it. So what they were trying to do was use reporting services like a slice and dice tool with lots of parameters to give them very small amounts of data. And I said, you're better with Power Pivot because it is designed for that type of scenario. So the idea is that you have different tools for different jobs. Yeah? So we have Power View and Power Map, and hopefully the internet access is okay, and then I can show you Power Map as well. But Power View is more for your business mystery person. It's highly visual. You don't need to learn coding. So if you're a reporting services person, you'll be really surprised to learn that Power View is actually part of reporting services, because they're honestly 2 different paradigms. Reporting services is very structured, very canned, but Power View is much more flexible. Okay, so the idea is that eventually we'll be moving towards having data mobile. Every single project I do, I always get asked about, can we put this on an iPad? It's just the way it is. Everybody wants the flashy gadget, but we have to be careful of that, because I keep saying to people, changing the gadget you use in order to access your data doesn't make your data right. I had one customer who I asked her about her data quality, because she said, I really want data on an iPad. I said, okay, what's your data quality like? And she thought for a minute. She said, I know my reports are about 60% correct. And I said, that's no good, because that means out of every 10 columns you show, 4 of them are wrong, which is a pretty close to 50-50 to me, whether your reports are right. So she said, yeah, but I just want it in iPad. I know which columns are wrong. And I said, well, what we need to do is talk about a data quality project, because otherwise it's garbage in, garbage out, and you'll be displaying garbage on an iPad. Just because it's on a little device doesn't make it pretty, or right necessarily. So this is a quick view of what Power View actually looks like, Power Map, sorry. It's a 3D visualization mapping tool, and you might have seen it in the keynote. They whiz data around the place, and it looks quite nice. I'm hoping I can get to access it here. Okay, so data where you want it. Now, one thing I would say is that in data visualization, colour theory is very important. Yeah? So we all know, hopefully we all know, not to use red and green together because it affects people who are colourblind. It can do. It also can affect people who have very thick glasses and are short-sighted, as I am. They get an effect sometimes where, if you look at it out of the corner of your glasses, you get an effect called chromatic aberration. And basically what that means is the colour splits, and you get a funny buzzing effect. It doesn't happen to everyone, but putting red and green very close together isn't such a good idea. Yeah. So, that said, one thing I am unhappy about with Power View is it doesn't allow you to change the colours other than the themes. And for me personally, I think I would love, if I could change one thing about Power View, it would be that. Because colour theory dictates you just don't have red and green together. And also, I think it's about the adoption of the tool as well. People don't like if colours fixed on them. You can spend ages preparing the data, and all the users want to know is, can I have it in red? Can I have it, in an exploding donut pie chart that bounces across the page? They just care about that, yeah? And you do get asked for all sorts. I'm sure you do as well. So one thing that they did introduce, and I'll show you this, is something called a motion chart. Now most of you have probably seen the charts with the bubbles going across the screen. There's a very famous gentleman called Hans Rosling. Has anybody heard of Hans Rosling? Yeah, most of you. Yeah, because I understand he's Swedish. I've never met him. I'd love to meet him one day. But he does that wonderful, it's on YouTube. He did it for the BBC, where he showed you the bubbles moving along the chart to show the world health and the life expectancy. So we move along the charts, everything moves along, and then we get to Rwanda and the 100-day massacre. You see the life expectancy drop and then back up again. So it's actually, the motion charts are a very powerful way of showing data very simply. Yeah, and you get insights from visualizations that move. Because something that happens very, very early on in our visual processing is we detect motion. It's one of the first things we detect, along with lines, blobs, shapes and colour. So we use the aspect of motion in order to help make the data more easy to understand. Plus business users love it, it's really easy to do and they like to see this sort of thing. For me, I like the idea of engaging people with their data. So you need to excuse me, I'm just going to I'm going to move to my virtual machine, so bear with me. Here we go. Right. What I'm going to do, I meant to say actually, probably a bit late to tell you, but if you go to I'm going to start up somewhere. Okay, so if you go to my blog, here, I've posted up the slides for today.
We can't see that.
You can't see that? All right, okay. You're right, you can. You can see my halo screensaver, look at me. That's good. Then you can't see anything. Where's it gone?
No.
Oh, it's here. Yeah, excellent, good. Oh, I always age at those moments. Oh. Then I think, why do I do this? I age myself constantly with things not working, and IT generally, you know. So if you go to my blog, today's entry, Stirrup.com, I've got the slides up there, so you can go and have a look at them. Stirrup.com. I think they will be uploading the slides to the SQL Pass website anyway, but I thought if you want to have a look at slides today, then you can go and do that. And I meant to tell you earlier, I'm sorry about that. Alright, so what we're going to do is something a bit different. We're going to talk about something that's related to Microsoft technology, but we're actually going to use big data. And now, big data is one of these buzzwords at the minute. Everyone's got, my data is bigger than yours, sort of thing, yeah? I've got a t-shirt that says that. My database is bigger than yours. So, the reason I thought I'd show you this is because I thought if I show you AdventureWorks, there will be a stampede for the door. Because AdventureWorks, although everybody loves AdventureWorks, that is very well known. So that's why I decided we'll look at Hortonworks for a change. Now, Hortonworks partnered with Microsoft, and you can download this virtual machine, and it is a virtual machine, for free. It doesn't look very pretty, I know. But what you do is, you download the virtual machine from the Hortonworks website, and all you do is point your browser towards the IP address that it gives you on the virtual machine. That's all you do. And then you go to your browser, leave that running in the background, and you get this really nice interface. Now what we're going to look at is, we're going to look at a way of analysing data, which is actually, it's a bit like SQL, it's called Hive. Now when we look at big data, we can't always use the SQL query language to examine our data. And the reason for that is when we look at big data, we are running queries over machines that are possibly hundreds or even thousands of machines together. And we're running queries over them. In SQL, as much as I love SQL Server, it needs to be used with other technologies in order to handle that sort of processing and that sort of load. I think because if you have so many machines together, you're running one query, and it's just so much data that you need to start to look at the big data technologies, not just for the volume of the data, but also the variety of it as well, because you can get structured data or unstructured data in there. So this is called Hive, which is Hadoop interface. It's basically we use an interface called Hue, and it means the Hadoop user experience. Yeah, and the reason I thought I'd use Hortonworks is because it's a bit different, and you might not have seen this before. So, just thinking about it. All right. So when we use Hive, it's actually called HiveQL, HQL, and the reason for that is it's very, very similar to SQL. It's a query language, very much like SQL. So it has a lot of the same functionality, and it uses a lot of the same keywords as SQL does. So we have select, we have the projection operator where you're telling SQL Server what you're going to do, so we have select. We also have a from, and all we're doing is select star from table. And although that's a very valid SQL query, it's actually a Hive query as well. So what I can do is run a quick query, which I'll show you. Oops, come back. Show tables. So it goes off. And all I've done is run a little command because I want to show you the tables that we're looking at. So it's going to go off. It should go off anyway. And it comes up with these two tables here. Now, when you upload data to the virtual machine, all you do is you've got a little file browser here, and you just upload the files at that point. Now, the interesting thing when you're dealing with Hadoop and dealing with Hive is that, and this confused me at first, which is why I'm telling you, because I had to work my way through understanding this, is normally in SQL Server, we talk about having data in a table. It's just how we talk. We naturally see data as being part of a table. If we use Excel, then we think the same thing, data in a table in a spreadsheet. But the thing with Hive is that you actually have a separation of the definition of the table and the data. So they're held in two separate places. So the data is stored in a file, and the table is a construct pretty much like a SQL Server view. It's a view of the data. Yeah? And that's all that's happening when we look at Hive. Because Hive does a few things. It's a structuring tool. So it takes the structures and unstructures data in a file and imposes a structure on it. So if we take one of these tables, so I've got two tables here. I've got one called country information and one is called HDI partition. I'll show you what is in both of these tables. So you'll create it now. So let's start from country information. If I can type that, that'd be good. Okay. So what we have here is, so let's start from country information. That's simple and it's a SQL query. It's also a Hive query as well. So the point I'm trying to make here is that most of you will write SQL probably on a daily basis, if not a weekly basis. If you have that skill set, you can actually transfer your skill set to learn big data technology as well. So it is accessible for you. It's not something that's removed. Because the thing is, I think with business intelligence, we're going to have to start looking at big data anyway. So I don't know about you, but a lot of the organisations that I deal with personally, they're just drowning in data. There's so much of it. And I'm starting to hear people say, well, I need to take a step back here. I've scaled up, I've scaled out with SQL Server, scaled up and out as much as I can, but I still have so much data. I need to take a step back and look at this from the architectural perspective. Am I doing the right thing? Am I using the right tool for the right job? So I'm not saying that you should go run out and dump your SQL servers right now. Yeah? I'm not likely to say that. What I'm trying to say is that you should use the right tool for the right job. And if you are running into a lot of very unstructured data and lots of high volumes of it, then you're better off perhaps looking at something like HDFS, Hadoop technology. You can't stay within the Microsoft sphere of things because Microsoft have just released the GA, general release, of HD Insight. And what HD Insight is, it's Microsoft's implementation of big data technology. What you do in Windows Azure is you store the data as an Azure blob, and then that is your big data. It's stored as a blob because it's structured and unstructured data. Your unstructured data could be things like videos or documents or something like that. Think of the sort of data you post onto Facebook, that sort of thing. So when you have that mix of structured and unstructured data, you can start to look at the Microsoft's distribution for big data. What are they doing? And it seems that they're trying to plan ahead for this. So we have so this virtual machine is a simulation, if you like, of big data. There's two ways I think you can learn about big data and analysing it. One is to use the free Hortonworks virtual machine, the sandbox, which you can download from their site. And that's what I'm using now. The second way to learn it is to have a Windows Azure account and sign up for HD Insight. You can get trials, but I suppose I wanted to give people alternatives of a free way to learn it, because if you are not a Microsoft partner, you won't have any free credits for Windows Azure, and I didn't want to ask you to pay to learn stuff, if that makes sense. Yeah. So here's our select statement here. It's a really simple one, and all it is country information. So the very first country we have is Afghanistan, and then we've got the currency here, for example. So we can actually go back and see what the query was, and it's just a really simple select star. Now we've got other queries as well we can run, and these will be quite familiar to you. So we could have a group by. So this actually looks like a SQL query. It's got select, it's got select then from, and then we've got group by down here. So some of the queries are very familiar to you, they're already something that you're quite familiar with. And here's a definition for creating a table. So what we have here is create table if not exists. And for most people that's very familiar from SQL anyway. They're creating a table. The only difference down here is the location. I hope you can see that, but you're actually telling Hadoop and Hortonworks exactly where the file data is stored, as well as the file definition. So that's the only difference really when you're creating a table. So let's go back and we'll have a look at the other table as well, HDI partition. So if you click on that, you can see that we've got our structures table which contains our data in it, and we can see a sample of the data here. So we've got levels of very high human development. You can see Sweden is here. Yeah, so one of the top countries. So I thought what might be interesting is to take these data samples and use those in PowerView. Because the thing with PowerView is that although it's very good for structured and for analysing and visualising data, it's actually one of the ways you could visualise big data sources as well. And what's nice about that is for the business user, they don't necessarily have to care that they're using big data at all. They can just get their PowerView with their model behind it, and all they need to do is click and tick. So we can mash up data sources, and I'll show you how we do that. So excuse me a minute, I'll just get my Excel up and running. Okay. So it's thinking about it? Yeah, thought about it? Good. Alright. Very happy to see that. So I'm just going to show you Power Pivot for a minute. Most of you will be familiar with Power Pivot by now, I suspect. Yep. So what we have here is you actually access the data stored on the virtual machine using ODBC. The nice thing is, because we actually access the data via ODBC, it opens it up to different data sources. So we can quite easily see the data in Excel and PowerView. Now, if there's one thing business users love, it's having data in Excel. It's their very favourite thing. I read a quote recently that said within 5 years, 50% of the world's data will be in Hadoop, but I don't think they'll get it shoehorned out of Excel first. I've been trying to get business users to stop hiding data in Excel for years, and it's never worked. Yeah. So I don't know who thinks up these statistics. Yeah. We'll definitely have a hard job getting it out of Excel. Not that I don't like Excel, I actually love Excel. I just don't like the way it's used sometimes. I had a customer a little while ago, and I worked for a company who were certain they had absolutely no Excel hiding anywhere. I spoke to one of the business analysts who said, I've got a spreadsheet to show you, and you never guess what was in this spreadsheet. It was a spreadsheet of her spreadsheets. Now when you think about that, she had so many spreadsheets, she had to have another spreadsheet to handle her spreadsheets. That's how many spreadsheets she had. So when she showed me this thing, this was a company that swore they had no Excel anywhere. My heart was just sinking, because she had 5 tabs, and by the time she got to the 45th spreadsheet, said, please, no more. I've had enough for one day. And I asked her, I said, do you back up? How do you back up this information? And she looks at me with the face of an angel. And she said, well, we pass it around by email. And it just, it's like kind of worms. It's like worst case scenario. So then I went back to the IT department and I said, they've got Excel everywhere. And said, no, they haven't. So, no, she has. They've all got it. It's everywhere. They're not using the stuff that you give them at all. And because I'm a consultant, I could drop that bomb and then just leave. You know? If people see me coming, it's trouble usually. So we can use ODBC to connect to those data sources. And all we do is normally, if this was a real live environment, you would do all of the querying in Hive, and you would run those queries and output the data to another table, which you could then suck into Power Pivot or access that way. The reason I say that is because if you're running Hive queries over hundreds, potentially thousands of machines, it's going to take some time. It's not going to run like that. It's not going to be super quick. Yeah? So lots of organisations already use Hive, and lots of organisations already use Hadoop, and you probably touch Hive every day and don't realise it. Who here uses Facebook? Most of you? Yeah. Facebook use Hive, believe it or not. They use Hive in order to help understand their advert placement. Those wonderful adverts you get at the right-hand side. Yeah. So it uses it for things like that and for their business intelligence. So last night I logged onto Facebook and it popped up on the right-hand side with an advert for Tableau and another one for ClickView. And I thought, they've summed me up pretty much. And then they gave me an advert for overweight women in cheap clothing, and I thought, well, you know, they haven't quite nailed it yet, you know. But they're nearly there, they're getting there. 2 out of 3 wasn't bad. So when we access the data in Hive, what we can do is you've got your Hive, you've run all your queries, you've output it to a table in Hadoop or in Windows Azure, and then you've accessed it using ODBC. Then we have it in Power Pivot, and you can start to set up relationships in the data. So this is our country information table that I showed you earlier. I didn't load it in again, I've obviously done this model previously, so I thought you don't want to be sat there, you know, with a hangover, some of you maybe, watching data transfer, you'll be falling asleep within a few minutes. So we have this table here. HDI is an interesting one. HDI is Human Development Index. Now, I'm happy talking about this in Sweden because you have one of the highest rates in the world for human development. So, pat in the back for you all. Because, you know, I keep hearing things about how nice it is to live in Sweden, and I think that's probably true. So the Human Development Index looks at things like access to education, access to sanitation, clean water, access and equality for women, these sort of issues. And the charities collect all of this data together and they aggregate it, call it the Human Development Index. So we're not looking at VentureWorks. The other thing that we do is we have the UNICEF report card. And the UNICEF report card is a really interesting piece of data. What they do is they go and ask children in different countries how they feel about their environments. Things like how many books at home do they have? That sort of thing. So they don't ask them if they're happy, they ask them things like, do they have access to books? And the surprising thing was, last year they showed that in the Czech Republic, children were more likely to have access to 10 or more books at home than in the United States. And that really surprised me, because I would have assumed it would be the other way. The American, obviously a very affluent country, I thought the children at home would be more likely to have access to more than 10 books. But maybe a surprise in the data, but maybe they're using Kindles and don't include that as a book, maybe, who knows. But when you start with these metrics, it becomes quite interesting. So we take the relationships in our data, we tie everything together. And then what we can do is, we have our model here in the right-hand side. So we have our list of countries. What we can do is we can add in a new sheet, and if we wanted, we can go and get some new data as well. So what we can do, if we go to Power Query, we go to Online Search, which is over here. Thinking about it. Then if we say if we can type in something like gross domestic product. What this does is it goes off to Bing. Oh, Croatia. No, let's not go with that. So it goes off. And it then tries to give you various data sources The nice thing about this is it's really easy to then copy it into Excel. All you do is click on it, and off it goes. It will go and get the data for you, and you can then add that data to the pivot model. So the nice thing about that is you're mixing up your big data with data from the internet, and you can then use internal data sources as well. So what we have here is just simply something we could add to the data model if we wanted. But what we'll do is, if you look at this data here, so this is a Power View map. So all I've done basically is you can go to Power View, and then you can go to Design, which should be kicking out somewhere. Yeah, there it is. And then we can change the type of visualization that we see. Now I know that Power View does not offer a lot of extensive visualizations in the same way as something like Tableau does or these other tools. The reason for that, I think, is it's very early on in the product adoption, so it's a new product. It's not as mature as the other ones. I think also they set out with the objective of trying to stick as closely as possible to the data visualization principles I spoke about earlier, keeping things as simple and clean as possible, minimising the data ink ratio. So basically they're trying to use as little ink to show as much data as possible. So we have that perspective as well. The only thing they get wrong, I think, is colour theory, but we'll have a look at that. Now when we look at data like this, it's really hard to navigate. It's a bit of a mess. But what we can start to do is, now this data is showing the high human development. So we can see that high human development are things like Europe and the United States. Or if you look at the one for very high human development, you can see it covers Sweden, covers Norway, Denmark, covers the UK, these regions. And we use colour in order to categorise, and we do that quite well, we do that quite effectively. Because when you look at example for the low human development, you can see for low human development, that's mainly over Africa and Southwest Asia as well. So we can see quite quickly categorising the data. And what we can do is start to mash up these sources as well. Okay. Now this is a version of a trellis chart. And for the trellis chart, all we need to do is we go to Design again, and then we can start to change it from a column chart. Now the thing about this is that we can filter as well, so we can do very high human development. Now the thing is, when people start to look at dashboards and reports, the way that they tend to do them is do a mix-up of summary data with detailed data. But actually there's some psychological research by a gentleman called Ben Schneiderman, and he talks about the golden rules of information visualization. If you can look it up, I recommend you do. Also, if you have some time, if you look up his presentations on YouTube, it's a really interesting, very engaging speaker. So what we have is, his research found that people like a summary of the data first, then they like to zoom and filter on the data, and then they like the detail as well. So that was his golden rules of information visualization. Give people a summary, then allow them to zoom and filter. And this is what the filters here have on the right hand side. Very high human development. And we try to filter on the data, but one thing that you need to watch out for is the axes. So what we see here, when we look at Indora, for example, some of the data is missing. Now if we change that chart so that it's all a line chart, when we do things as a line, it's not as obvious that some of the data is missing always. So if you do something in reporting services and you do something quite similar to a trellis chart, make sure the axes are aligned, because it can be really misleading if they're not. And it can be really hard in a line chart to see that data is missing. So what I tend to do is do a line chart, then do a bar chart, just to see if any of the bars are missing, and then put it back to a line chart. Because the thing is, data visualization certainly picks up if any of your data is bad quality, but it's very difficult sometimes to identify missing data. So just a very quick scan to see if data is missing. Because if, for example, you include nulls, the number of nulls in an average, it can really skew your average because you've still divided by the number of records, even if some of those are nulls. So we have to be careful with this sort of thing. So one thing I was going to show you is we have the happiness index, and one thing, it's just a daft thing. I did this to cheer you up, yeah, so you like it. So what I did was, we look at Power Pivot, go to Manage, and what I have here is we've got something here called the happiness index, and all I've done is made a really, really simple rank, and basically I've ranked the countries, and the top 10 countries I've marked as a J, and the bottom 10 countries I've marked with a K. And I'll show you why I've done that. Because then if you go back to Excel, and when I've got a slicer here, and if you put the slicer and then make it an ordinary one like the orange one here, you can probably see that one's a J and one's a K. But if you use wingdings, yes, I did mention wingdings, as bad as Comic Sans Serif, I think. If you use a slicer with wingdings in it, then what it does give you is access to the little icons, so you can use smiley faces. And it probably sounds a really daft thing, but if you show a business user something that's got true and false in it with capital letters, they don't like it, especially if you have a lot of slices with true and false in them. But if you can use pictures, it just makes them feel warm and fuzzy, yeah? And it means that you've had a great morning looking at Wingdings character maps, and they're really easy to do. And it just makes, if it makes your business users happy, then that's a good thing for me. And it just means you can filter by it as well. So we look for the happiest places to live, and we see that Sweden is number 2, yeah? So that's well done here, that's good. I did this session in Greece, it didn't go down so well. I should have thought about that before I went in. Never mind, live and learn. So I'm going to do it for the Netherlands. So what we can do is, it's really easy just to use a mixture of Excel and Power View to start to give business users what they want in order to understand the data a bit better. And I've just realised that the time is just 2 minutes to 10, and I've probably wobbled on long enough. I wonder, does anyone get any questions? Or? Well, in that case, I'll thank you all very much for coming, and if I were you, I'd rush to get the coffee, and I'll be outside if anyone's got any comments.